Hello all, my name is Puranik. I am a trainer for Tata Technologies and training content developer for iGetIt. Today I am going to deliver a webinar on how to create table function servo motors in kinematic design of mechanisms. So this will be a brief introduction about one of the topics of mechanism. There are some details and more given in our course on the mechanism design, and that course is coming soon. So the course will be like this, where all the topics related to mechanism design are explained. So please watch this place, where you will definitely get the updates about when this course is being released. Okay, so in this assembly, this is the toe jack, and we know that a toe jack works on a principle of Pascal's law, wherein when we push this handle, then the small piston goes down, and that motion of this piston going down, ultimately that motion gives the upward motion of this big piston, and that will lift the weight over here. That is the basic principle of this toe jack, and that works on the principles of hydraulics. So this assembly is entirely created, and if we see this right section with the show section and in the right view, so we can see that the small piston is at this position with respect to this base plate surface, and the big piston is over here. So there is some distance available for the big piston from this surface, also for the small piston from this surface, and the current position of both these pistons is currently the 0 position. So this assembly can be explained briefly like this. The base plate part is a fixed part in the context of mechanism. Then the small piston, it is having one joint that I will show in the mechanism, but that joint is nothing but a slider which will allow the small piston to slide in this hole up and down. Then the small lead, which is a fixed one with respect to the base plate, and that fixing is done with the help of these small screws. Then there is a big piston which is also having a slider joint, and that will slide inside this hole over here. Again, big lead that is fixed over here on the base plate with respect to these screws. And there are some washers, like one washer over here that will help the sliding of small piston. Then there is one more washer over here that will help the sliding of big piston. Then there is one ring over here on the top of small piston, and that is used to hold the next part, which is nothing but the rocker. So this rocker is having a pin joint over here which will allow it to rotate along this pivot. Then there is a rocker arm. So this is again having one pin joint over here and another cylinder joint over here. Then comes the rocker screw, which is for the purpose of holding the rocker over here. Then there is one screw, with the help of that this part is held, the rocker arm. Then the rocking arm. So this is the thing which the user will use to give some force. The force will be applied over here, and due to the small force of any person, this small force will be converted to a larger force, and that will be lifting the weight over here. That is the concept. So there is a main slider over here, and that is having a rigid connection with respect to this big piston. That's why when big piston moves, then this slider will also move, and on the main slider there is a dead weight kept, so the weight will be lifted. That is the whole idea of this mechanism. So now let us see the connections. If we go to applications and mechanisms, so here you will find the connections like this is the slider joint for this small piston that is going in downward direction. Then again slider for the big piston that goes in upward direction. Then again one slider joint for the main slider part, and then over here a cylinder joint, and these two are pin joints. So these many are the connections over here. And now we are going to see today's topic, that is nothing but how to create a table function servo motor. So when any operator handles this toe jack, he is going to put a pressure over here, and then when he will put the pressure, each time he will move that part, this one, the rocking arm, he will move his rocking arm by some distance gradually, and with the help of many movements of his hand, ultimately this thing will totally take that small piston down, and in turn the big piston will come upwards. So we need to replicate the same kind of motion over here with the help of a motor, because our current focus is on kinematics of mechanism and not on dynamics. So I will go for a servo motor, and it will be in a driven quantity as a position, because I am interested in the position of this small piston, how the position of this piston changes. So first thing, I will give it a proper name like small piston downward motion. That is the name. Then as a reference for this motion, I will select this slider joint over here for the small piston, and the direction is downward. That is okay for me right now, and the driven quantity is position. So in the profile, currently I want to create a function that is nothing but a table function. So that is over here. There are many other functions which you can see in detail in the mechanism design course of I Get It. So when I want to use this table function, I need to vary the position of that small piston with respect to time. So that's why there are two columns over here. One is variable value, there is nothing but the time variable, and driven quantity is the position. So I need to define a analysis for 12 seconds. That's why. So this is my first row over here, that is for 0 second, and then I want to go it up to 12 seconds. So let me add some more rows. 1 2 3 4 5. So 6 7 8 9 10 11 12 13. Okay, so when there are 13 rows, then it can go up to 12 seconds. So first is 0 seconds, then second is 1 second, 2 second, 3 second. Likewise, let me enter here all the values of time variable in terms of seconds. Then I need to define the value of motion. There is nothing but the position, because that is the driven quantity. So what will be the position of small piston at what time interval, that I need to specify. So I am giving the values like this. Okay, so this is the definition of table motion, that at 1 second it is 8 as the position, for, at 2 seconds 8.5, then for 3 it is 9, 4 it is 17, 5 it is 17.5 and so on. So maximum displacement of small piston is going up to 36 mm. So if I see the graph of this motion, it will show me like this. So it will indicate that it is having intermittent motion. The position is increasing in a intermittent manner. That is the graph over here, and direction is downwards. That is okay. So this first motor is defined, and then let me just copy this name of this motor. Okay, so first motor comes over here in the features, as well as it comes over here. Then let me define the next motor. Also the motor is showing over here with this symbol. Then I will go for servo motor again. That will be for the big piston slider axis, and that is upwards. That is okay. So I just need to give it a name. I will say big piston, and big piston is going up, so it will be upward motion. Okay, so the name is proper, big piston upward motion. Then let me define the table function servo motor again. So again, let me first add 13 rows. Okay, so the variable, time variable, okay, then the values. So in the small piston, the maximum limit of motion was from 0 to 100, and in this big piston it is from 0 to 150. So that's why I need to define the driven quantity, the position within that range. So here the value should be like this. And the maximum displacement over here, that is 120. Okay, so then if we see the graph, again the graph shows in a same manner intermittent increase in the position of that big piston, and I make sure that the direction is upwards, and this thing is done. Then once the operator takes this small piston down, and when the big piston goes up, so in general, if we see the application like this, toe jack is lifting the bed of a lathe machine. So once the lathe bed is lifted up, then operator has to do some other task over there till the moment his task is finishing. Then the lathe bed has to be remain at that same position, and once the task is done, then this should gradually move down so that there is no damage to the lathe bed, and safely the pressure is being released over there from the hydraulic oil. So that's why there is somewhere here one pressure release valve located, which I have not shown over here, but in actual toe jack there is somewhere here a pressure release valve, and when we use that valve to release the pressure, then gradually the big piston will come down, and gradually the small piston will go up, and in that case there is no intermittent motion, that is a smooth motion. So we need to show that motion as well, and for that I need to again create two motors. So let me again copy this name for small piston, and I will again add a servo motor to the small piston axis, but now this time it should move up because the small piston is moving upwards in a second motion. So that's why I will first flip the direction, it will go upwards, and this time I will control the velocity and not the position. So it should be a position motor, the velocity motor, and it should be in a mm/second as the unit, and it will be a constant velocity. So I will give it a constant velocity, and that will be 12 mm/second, then a proper naming. So it is now small piston upward motion. So let me just change the name over here. Okay, so small piston upward motion is the name of this motor. The direction is proper, and when this is going up, then big piston is coming down, so there will be one more motor for that as well. Let me first copy the name of this big piston motor and a servo motor for big piston axis, but it should not be upward, it should be downward. So again flip the axis, it is downward going, then a velocity. The velocity should be again constant, it should be 40 mm/second, and see now the constant velocity shows a straight line as a graph, and let me give it a name, big piston downward motion. And this naming is very important because when I am analyzing the motion, I can easily understand which motor to use where. So small piston downward, big piston upward, these two are the position motors with table function, and small piston upward and big piston downward, they are velocity motions, and that is also shown over here, position first two motors and velocity second two motors. So with this now I need to define the analysis. So here in the analysis I will go for new analysis, and I will give it a name as toe jack motion, and I will define the analysis in a position manner, not in a kinematic manner, and this should be from start time as 0 second and end time as 30 seconds. Then there are motors, so all the motors are coming over here, but I need to modify the sequence over there. So first should be small piston down and big piston up. So small piston down motion is there, big piston up motion is there. Okay, good. So this should be for first one as from start to 12 seconds, that is small piston downward, and big piston upward should also be from start to 12 seconds. So once it is going, the small piston is going down and big piston is going up, then it has to be held over there for some time. So I am giving that thing the holding time as a 15 seconds time. That's why for the small piston upward and big piston downward, these both motions, I will say start time to be 27 seconds and 27 seconds over here as well. So it should be 3 seconds up to end, and that will have the proper motion, because for small piston the total travel is 36, so 3 seconds again it will come down with the 12 mm/second as velocity, and for big piston the total travel was 120. So again for that the motion was 40 mm/second, that will again take it down in a 3 seconds. So this is the proper definition of the mechanism, and I will say OK for the definition of analysis, and the analysis comes over here. Then now let us check whether what I intended is that thing working or not. So if I say run over here for the mechanism, so it will show the motion properly. We can check that in playback as well. So here as well, it is coming down, it is going up, then it is being held for 12 seconds, and then everything is going back to the original position smoothly. So let me just change it. This, I don't want to repeat this animation. Okay, so this is okay, and let us see it now again. So it is properly going down, then it is held over there, and then smoothly returning to the 0 position. So this is a brief about how to create a table function servo motor and how to analyze the mechanism. I hope that you must have got some useful insights to your knowledge base of mechanism design, and if you want to see something more, if you want to study and understand the mechanism kinematic design in detail, then I request you that please visit our I Get It page and subscribe to this mechanism design course, which is going to be released soon. Thank you for attending the webinar. Thanks a lot.